All right, so we're going to continue talking about solving and simplifying trig equations using identities. So we're going to start with this problem right here. Okay, so if I want to simplify this, I see that I have squared, so my mind goes to Pythagorean identities, and I would want to use them. However, I also see that I'm multiplying fractions, and I can kind of see how stuff cancels out a little bit. So I'm going to hold off on the identities just yet because I see sine, and I see cosine, I see possible squared, so that could give me cancellation. So I essentially have 4 cosine squared of t over sine squared of t times a sine squared of t over a 16 cosine squared of t. Because in that second term expression, the squared applies to the numerator and to everything in the denominator, so everything got squared. The t's did not get squared because the t's are inside the trig function, so they're kind of immune to that squaring effect. Okay? So now that I have this, here's what I would want to do. Well, I'm multiplying, so I can kind of from here see that I'm going to have a sine squared and a sine squared, so those will cancel out, reduce down to give me 1. I see cosine squared divided by a cosine squared, so those will cancel and give me 1s as well. And then I see 4 and 16, and I know, well, I can divide both of those by 4, so I get 1 and 4 left over, right? So notice, even though from the first step I saw that I had squared, so my instinct was to maybe use Pythagorean identities, it's actually a lot easier if I try something else out, see that stuff cancels, and then I'm just left with 1/4 as an answer. If you would have tried to do Pythagorean identities, you can do that. You can do that. It's just it might be a little more complicated as you try to solve it. But just from visualizing the problem and seeing that I could have gotten a sine squared from here and a cosine squared from there, just doing that little calculation in my head helps make this a little more efficient. So let's try another one while we're at it. Okay, so now we have this one. This is going to be fun. So from the looks of it, I have 1 minus tangent squared of t divided by 1 plus a tangent squared of t. And on top of that, I'm adding 2 sine squared to it. So I need to figure out how to do this. I don't see where the sines and tangents can kind of combine. So I'm not going to try to do what I just did. I'm actually going to look towards a Pythagorean identity. Trying something out and see how it goes. I haven't worked this out, so bear with me. So I know that sine squared plus cosine squared should equal 1. And going back to what I was doing yesterday where I explained how to get it, I could derive, if I divide everything here by a cosine squared, I could get tangent squared plus 1 equals secant squared. And if you notice, that should be another one of your identities that you have. All right. And here's what I do see. I can do a little substitution here. I see tangent squared plus 1. I see 1 plus tangent squared. So my mind is, all right, let me just simplify that first fraction, see what I end up with, and then I'll worry about the other part. Or I could also try to put them in the same denominator, but I just, all right, yeah, okay. Let's see what we do. So we have 1 we have 1 minus tangent squared over secant squared according to our Pythagorean identities plus 2 sine squared of t. So I'm going to do it both ways, where the two thoughts that popped into my head were, okay, let me simplify the one fraction and then worry about adding it. Then my second thought was, no, let me just try to put them all into one giant fraction and hope for the best. All right. So I'm going to do the first way, simplifying the one fraction and seeing what that gets me. Then I'll revisit it at this step and do it where I have the same denominator. So, I don't have an identity for 1 minus tangent squared. So what I could do is I could take the identity that's already given to me that I highlighted and say that tangent squared is equal to secant squared minus 1. And the reason I thought to do that was because I have a secant here, and it'd be really nice if I could get that kind of secant to cancel out, but I can't do it if I have a secant and a tangent, right? I mean, like, I could, but yeah. See, and this is what I'm saying. Like, you have so many choices. It's just go with what your gut is telling you. Try it out and see what happens. So if I do that substitution, I end up with 1 minus secant squared of t minus 1 over secant squared plus 2 sine squared of t. All right, and if I keep that going and simplify the numerator, I should have 2 minus secant squared of t divided by secant squared of t plus 2 sine squared of t. All right, and now I'm going to choose to do my dividing. I'm going to break this up into two fractions, so it's going to be 2 over secant squared minus secant squared over secant squared plus 2 sine squared of t. This is just going to be minus 1. This will still be 2 sine squared of t, and this will be 2 over secant squared. So as you see, I made some progress. I took that fraction, and rather than having two terms in the numerator, I now am down to one term. But I don't like the fact that I still have a fraction. So drawing back to my identities, I see 2 over secant squared, and I think, aha, well, cosine is equal to 1 over secant. So then cosine squared should be equal to 1 over secant squared. But it's not 1, it's 2, so I can replace yeah. So I'm going to think about replacing this right here as 2 times 1 over secant squared minus 1 plus 2 sine squared of t. And I know that's going to be 2 cosine squared of t minus 1 plus 2 sine squared of t minus 1. Okay. And I'm going to do another step to rewrite, and I'm almost done actually. Because now that I've done this so much, I can kind of see how it's going to play out from here. So I'm going to think about it as 2 cosine squared of t plus 2 sine squared of t minus 1. And the reason I do that is because I know that cosine squared plus sine squared is an identity. Specifically, I know cosine squared plus sine squared equals 1. So I'm going to view it as 2 times cosine squared plus sine squared. Right? That's still equivalent to the previous step, minus 1. So this is really 2 times 1 minus 1. So my final answer is a 1. Notice that this problem is all about knowing the identities that are available to me, making a choice of when to substitute it in, and just being able to draw from your algebra skills to help you simplify things along the way. So that's one way. So I figure out this answer should be a 1. All right. It'll get there. It'll get there. Okay. So I've just learned this answer should come out to 1. So I said at this stage right here is where I would restart, where I could do this to have just one fraction rather than split it up into, rather than work with just one fraction, I want to make it a giant fraction with the same denominator. So here I go. Okay. So I need to rewrite this expression so it has a common denominator with the first fraction. So I have 1 minus tangent squared divided by a secant squared. So my denominator should be a secant squared plus 2 sine squared of t secant squared of t over secant squared of t. Okay. And so here I go. This looks messy. Maybe I made a mistake. But wait a minute. Secant is 1 over cosine. So then secant squared is 1 over cosine squared. So I'm going to replace this secant squared with the 1 over cosine squared with 1 over cosine squared, because I think I can make a tangent, and that would give me a common term with the numerators, so then I can combine like terms. So I see it, so I'm going to do that. All right. So again, I saw something, so I'm going to run with it, and I was able to think about making like terms in the numerator. So in essence, I have 1 minus tangent squared of t over secant squared of t plus 2 sine of squared, technically over 1 times 1 over cosine squared of t over secant squared of t, right? Because this is where that substitution came into play. So if I combine these two into one expression, 1 minus tangent squared of t over secant squared plus 2 sine squared over cosine squared over secant squared. All right. I know according to the quotient identity, tangent is equal to sine divided by cosine. So I can replace this with a tangent squared. All right, and I'm showing you step by step so you don't get lost in my process as you're viewing this video, and hopefully you're not too far lost and you just have a lot of why would you do that moments. But again, it's just a vision and intuition that I'm trying to help you develop, and it takes a lot of practice right now to get good. All right, so this is what I get from combining my numerators, and I can do that since they have the same denominator, so I made it into one giant fraction. All right, oh, that should be a squared, not a that. So then from here, I get 1 plus tangent squared of t over secant squared. And I know I've seen this before. This is actually what I used for my substitution to begin with. So I can say this is just secant squared over secant squared. And lo and behold, I got the 1 again, right? Because this was my Pythagorean identity. So notice, I just found 2 ways to get the same answer. I used similar identities to do it. The only thing that changed was the order in which I applied them. And there is no right way. The first method versus the second method, they're both equally valid. It's just a matter of what you see and how you simplify it. So be patient. Hope this helps. And if not, we're just going to keep giving you more practice so you can kind of see and develop a little bit of vision. I would also keep the identity sheet kind of handy so you can work through this and be like, oh, there's that recall. Okay?